for some reason, everyone seems to have a different heuristic that they like, and they just kind of stick to it. Probably the best answer I can give you is do a 50-50 split. Why? Because who knows? At least that way you're giving equal portions to your training and your validation. Most people usually get the opinion of it's better to have it trained better than to know that it's trained better. And so you usually end up doing some kind of 75-25 type split. But you don't want to have an insignificant amount for your validation set, or it's defeating the point of validation. Okay? I happen to like using a 36% portion for validation and a 64% portion for my training. Why? Because 36 is 6 squared and 64 is 8 squared. And if you take 0.6 and 0.8, and square them both and add them together, it makes exactly 1, which happens to work kind of nicely. It has all kinds of weird triangle equality properties, and it just seems like a nice proportion. And so I like to pretend that there's some magical natural value to those numbers. Of course, that's being superstitious and weird and has nothing to do with anything. So I don't know, split it about evenly, or maybe lean a little more towards training, because most people do. I don't think there's any great reason to do that. I just think a lot of people do because they want to make sure it's trained as well as possible. Yeah.
In the art file that you gave us,
Yes.
The fourth to last and third to last attributes are TVG measured and TVG real. If the TVG is never measured though, every value for TVG real is just a question mark. So whenever we put it through the inputter file, it doesn't have a mode, and it just thinks it's a question mark, which then transfers to a negative value in Java.
Ah, okay, excellent point. So you're saying some of these columns are completely missing, and then so the missing value imputer doesn't even work properly. Okay. Well, so thank you for finding a bug in my code. That's awesome. And next, how should we deal with that? Yeah, just remove the column would be a great solution, right? So go ahead and just remove the column if you want to. How could we rewrite my imputer so that it can handle this case? Because obviously I didn't plan for that. The column with absolutely no values in it, that just shouldn't happen, right?
If you can't calculate it, throw it away.
Yeah, if you can't calculate it, throw it away. You might as well just fill it all with the number 1. That's a good number, right? Or how about 0? 0 is a good number. And what's it going to do if you add a bunch of zeros to the column?
It's not going to affect anything. Or it's not going to update.
In theory, it would have no effect. In practice, it actually does. So if you add a bunch of garbage columns, it turns out it slows down the training just a little bit, not a lot. So what'll happen is the neural network will learn, hey, it's always the same value. That doesn't help me predict anything. The weights on it will eventually go to 0. But it does take some time for them to go to 0. So every attribute of garbage you add slows down your effectiveness a little bit. And it'd be better to remove it. But if you leave it, that'll work too. Just wait a little bit longer. Okay, yeah.
It also seems like the load arc method had trouble in the Java code with the attribute that has space in the name.
Okay, yeah, somebody pointed that out in the forum, and I just need to apologize for being so darn busy lately. People have dumped a lot of stuff on my plate, and I just haven't gotten to fix this yet. So, yeah, there's a bug in there. Apparently a solution was posted on the forum, so I guess the answer is go plug that solution in, and that should fix your problem. Is that fair? Okay. I would really like to hand out a better starter kit to the next generation, so I will intend to go fix that. And yeah, do I need to look at that? Where are there spaces in there? I guess.
It was in the attribute, right where
Oh, so the problem is while parsing this section, because there are spaces before the F, it freaks out and says...
Space in the name of the attribute.
Hypothyroid, there's a space in it.
Oh, you're saying those quotation marks don't properly indicate that that thing's a space. Okay. Well, a few easy solutions. One is just go insert an underscore into your text file right there, and then you don't even have to deal with the code. Two, go look in the code and figure out what's wrong and fix it. Yeah. I'm just going to say easiest solution is probably touch up your data set because it's only going to occur in those few places. I apologize for that. I should have had a robust load_arf function. I thought it was because I've been using it for years, but I've never tried this data set. And well, whoops, I messed up.
If we touch up our data set, should we submit it with our code when we turn it on?
Yeah, this one is so small relative to MNIST that it's not going to cause problems. Go ahead and just submit it with your code. By the way, a few comments on that. So I've been grading the MNIST one. I've got them 80% graded, but the remainder are just giving me all kinds of trouble. I must rebuke you all for not following instructions. The actual instructions said, just print out your results so I wouldn't have to wait for them. A lot of you are actually loading MNIST and generating the results, and some of them I've been waiting for, you know, an hour plus, and I'm not seeing output yet. That's kind of painful for me. So I'm going to start, I'll try a little bit more because, you know, I want to do my due diligence and give credit where you guys have worked hard, but pretty soon I'm going to start kicking them back to you and say, hey, you run it on your machine and then give me what I asked for, because, you know, I'm working too hard to try and give you credit on this assignment. A couple other things. You Windows users haven't gone into that make file and removed those -W shadow lines. It's still causing me grief, and I'm having to fix it every time to test it. A lot of you Java users haven't fixed that one bug in my load_arf function at the end where I didn't check for null before throwing a exception for the file not found. It'd be nice if you'd go fix that. In the end, I got to admit, these are all my bugs. I don't know how they managed to get this far without students finding them. But so yeah, it's my fault, but if you'd help me out a little, that would be great. And I'll give you feedback on your previous assignment really, really soon. Sorry it's taking me so long. Okay. Anything else on this assignment? Do you understand momentum and batch and those things? You know how to make charts. I think we're ready to put this one to bed. Yeah. Okay, before I use up all of my time, let's make sure we have enough for reviewing for the test. Midterm test. This one will be in class. You will need a pen and paper. No, you won't need to bring paper. I will bring the paper. So I will hand out the test. You need a pen or a pencil. And do bring a calculator. Here's why. I've been thinking about the questions I can ask on it, and there's only so many. And so let's talk about what those questions will be, and then you'll see why you'll probably need a calculator, because several of the questions I can think of might need one. I usually like to touch up the numbers so that you don't really need a calculator, but it would still usually make you feel better, right? Just when you're on taking a test and you're under pressure and you can't remember 6 times 8, it's nice to just type it into the dumb calculator and know and not worry about, oh no, did I remember my times tables correctly, right? So I recommend bringing a calculator anyway. I'll let you use your phones. You're graduate students. I don't think you're going to be texting someone outside to cheat anymore. But, you know, if you do, they throw the book really hard at grad students that cheat. So don't try. You have been warned. But let's see, what else? I guess that's all the logistics. We'll just do it in class. Then afterwards, you'll hand them in. I'll have them graded within a few days. Yeah.
Is it essay format?
It'll probably be more short answer. Like, I'll ask some questions, you'll do some math and write down your answers type questions. When I ask short answers like, why do we use momentum or something like that, please don't tell me everything you know. I really don't want to hear about everything you learned throughout your entire life. Just answer the question, okay? I'll consider that to be a negative thing if you just start brain dumping. that kind of suggests you don't know, and I'm not going to play the game where I'm going to dig through everything you write for the right answer, and if I find it, give you full credit. It's more of a, I'm going to look at your answer and see if that answer represents that you know what you're talking about and judge based on that. So it's better to just answer the question than to try to game it. Yes?
Is it open book?
We'll say no. However, don't go out and start memorizing obscure details. I'm not going to ask you, what is the equation for computing m in ordinary least squares? But I would very likely ask you a question such as, here is the equation for computing m in ordinary least squares, and here's a little bit of data, and it'll be some really tiny problem that would be easy to deal with. Please tell me what m is. And then you'd have to do the math, and you'd have to remember how to multiply a matrix by a vector and something like that. The one problem with that question is there's a matrix inversion step. And there's no way in heck I can make you do a matrix inversion on a test with paper and a calculator, right? So,
2 by 2.
yeah, I guess if it's 2 by 2, you could do Gaussian elimination, but that's kind of beyond what I'm going to expect. So if I go with that question, then the way to answer it would be get to the point where you do matrix inversion and then say, and then I invert it. And then there's your answer, right? So it's totally okay to not work out the math as long as you specify it correctly. On the other hand, it's not okay to just say, your answer is 2 times 4 plus 1, because you can do that math, right? So that would be not simple enough, whereas if you'd say the answer is hyperbolic tangent of 4.3, that would be simple enough to be a correct answer. If you were to say the answer is, if you gave a big long equation with addition that you hadn't resolved, I'll say that's not simple enough. Is that clear enough? Okay. So here's the major topics we've talked about. We started with OLS, right? Because we did an assignment on OLS. Because we did an assignment on it, I expect you to know it really well. Basically, anything that was in an assignment, I really want my grades to be assignment based. I feel like assignments teach more than anything. So my main goal is just to make sure you got out of the assignment what you should have, as opposed to somehow you got it done by working in a group and didn't really understand what you were doing, right? So I'll try to ask questions like, hey, you did this in an assignment. What did that mean? What was that about? Why did you do that? Type thing. And if you understood your assignments, hopefully you won't need to study for this test. You'll just do great. That's my goal. I don't know how well I'll achieve it. So first thing we talk about is OLS and linear regression. And you should certainly understand sum squared error and mean squared error and root mean squared error. Those are kind of the 3 main metrics we've talked about. And you should probably know about, here, let's make a list of stuff. Sum squared error, mean squared error, root mean squared error. We just talked about Hamming distance, so you got that one down now, right? You better know Euclidean distance, not because I taught it, but just because you're grad students and that's a basic thing to know. And these are kind of the main error metrics we know. You should know that we usually start with sum squared error, and from that we derived backpropagation, right? That was a major assignment that we did, is you implemented backpropagation, and we also spent a lot of class time deriving backpropagation, so I'd expect you to know it. You should be able to kind of work through the math to derive it, and you should be able to do it. If I gave you an empirical example, I say, here's a couple of numbers, here's a neural network with this topology, show me what would be the output of feed forward, by which I mean activate. What would be the error on the output layer? What would backpropagation compute? Those kind of things. And then you could use your calculator to do the numbers, or I could say, here's a simple linear equation, derive the gradient for it. Something like that. And then you do it mathematically and you show me the equation for the gradient of a linear model. That would be a pretty good question, I think. Okay.